Good day everyone, my name is Karen Picotinho and today we'll be having a video tutorial in biotechnology, particularly in biological fuel generation with the following topics like methane, hydrogen, the way ahead for biofuels, contrasting views in climate change, as well as the research article related to the topics being mentioned. Now let's start with methane. What is methane? Methane is a colorless and odorless gas that occurs abundantly in nature and as a product of certain human activities. Methane is the simplest member of the paraffin series of hydrocarbons and is among the most potent of greenhouse gases. Its chemical formula is CH4, which means that it is composed of one atom of carbon and four atoms of hydrogen. Talking about chemical composition of methane, it is lighter than air, having a specific gravity of 0.554. It is only slightly soluble in water and burns readily in air, forming carbon dioxide and water vapor. The flame is pale, slightly luminous, and very hot. As you can see here in the illustration is the tetrahedral structure of methane. It is explained by the valence shell electron pair repulsion theory of molecular shape by supposing that the four pairs of bonding electrons, which are represented by the gray clouds, this one, adopt positions that minimize their mutual repulsion. Where can we find or what are the sources of methane? Methane is produced by the breakdown or decay of organic material and can be introduced into the atmosphere by either natural processes such as the decay of plant material in wetlands, the seepage of gas from underground deposits, or the digestion of food by cattle, or even human activities such as oil and gas production, rice farming, or waste management. There are plenty of uses of methane. Methane is an important source of hydrogen and some organic chemicals. Methane reacts with steam at high temperatures to yield carbon monoxide and hydrogen. The latter is used in the manufacture of ammonia for fertilizers and explosives. Other valuable chemicals derived from the methane include methanol, chloroform, carbon tetrachloride, and nitromethane. The incomplete combustion of methane yields carbon black, which is widely used as a reinforcing agent and rubber used for automobile tires. If we have advantages, we do also have disadvantages of methane, and these are the following. One is, it is the main contributor to global warming. It is said that methane is 84 times potent than carbon dioxide. That is why it absorbs heat from the sun, making our planet Earth more hot. Second, it is very dangerous to human body. Third, when there is high enough concentrations of methane in the air, this can result in suffocation of air-breathing creatures. And lastly, it is highly explosive. Second is all about hydrogen. What is hydrogen? It is the chemical element with the symbol H and the atomic number is 1. With a standard atomic weight of 1.008, hydrogen is the lightest element in the periodic table, and it is the most abundant chemical substance in the universe, constituting roughly 75% of all per unit mass. About the chemical composition of hydrogen, it is highly flammable and will burn in air at a very wide range of concentrations between 4% and 75% by volume. Hydrogen thus form compounds with most elements despite its stability. When participating in reactions, hydrogen can have partial positive charge when reacting with more electronegative elements such as the halogens or oxygen, but it can have a partial negative charge when reacting with more electropositive elements such as the alkali metals. What are the sources, or how is hydrogen being produced? So hydrogen can be produced in various or in diverse domestic resources. We do have fossil fuels like the natural gas, as well also the electricity from the grid or from renewable sources such as the wind, solar, geothermal, or biomass. We also have plenty of uses of hydrogen. Some see hydrogen gas as the clean fuel of the future, since hydrogen can be generated from water and returning to water when it is oxidized. Hydrogen-powered fuel cells are increasingly being seen as pollution-free sources of energy and are now being used in some buses and cars. In chemical industry, it is used to make ammonia for agricultural fertilizer in the process called Haber process, and cyclohexene and methanol, which are intermediates in the production of plastics and pharmaceuticals. In the glass industry, hydrogen is used as a protective atmosphere for making flat glass sheets. And in the electronic industry, it is used as a flushing gas during the manufacture of silicon chips. We have also disadvantages of hydrogen. First, hydrogen energy is expensive. The process of extracting hydrogen is too expensive that only rich countries can perform it. That is why hydrogen is not used, or not only few countries use hydrogen across the world. Second is storage complication. It is very complicated to store hydrogen because hydrogen is less dense, that it requires high pressure in the storage of it. Third, it's not the safest source of energy. Fourth, it is tricky to move around. And lastly, hydrogen energy cannot sustain the population. The fourth subtopic is the way ahead about biofuels. Biofuels are renewable energy source made from organic matter or waste that can play a valuable role in reducing carbon dioxide emissions. Biofuels are one of the largest sources of renewable energy in use today. In the transport sector, they are blended with existing fuels such as gasoline and diesel. World energy needs at present are dominated by the continued adaptability of fossil fuels, the same fossil fuels that we are now realize are causing continued and permanent damage to the world climates. The ability of biofuels to realistically enter the energy market will be determined by several factors. First, the availability of the existing energy chain to biofuels. Second, the resistance to the application of biofuels by the current energy management. Third, the ability to reduce the costs of biofuels. And lastly is the retrofitting of the existing energy supply chain to accommodate biofuels. And here are some positive indicators about the development of global energy situation. First, developing new biofuel components and improving the efficiency and flexibility of those currently blended with transport fuels. Second is devising new technologies to enhance and accelerate the conversion of organic matter to biofuel molecules with the aim of increasing the proportion of a crop that can be used to produce feedstock. And lastly is using modern plant science to develop species that produce a higher yield of energy molecules and can be grown on land not suitable for food production. Lastly is contrasting views on climate change. Climate change is a change in the pattern of weather and related changes in oceans, land surfaces, and ice sheets occurring over time scales or decades or longer. Climate change happens because when fossil fuels are burned, they release carbon dioxide and the greenhouse gases, which in turn trap heat in our atmosphere, making it the primary contributor of the global warming, or the reason why there is a continuous increase of global temperature. It is said that climate system is hugely complex. Up to the present time, it is believed that no computer modeling is sufficiently accurate for the prediction of future climate to be fully relied upon. And as you can see in the screen are the common phenomena that is happening at the present because of the continuous global warming and climate change. And these are flooding, melting of glaciers, rising sea levels, worsening droughts, increasing tornadoes, and supercell storms. For my research article, the title is Bioelectricity Generation from Agro-Industrial Wastewater Using Dual-Chambered Microbial Fuel Cell. It is by Mustafa et al. And published in February 2020. The objective of the study is to demonstrate and evaluate the electricity generated by double-chamber air cathodic MFC while reducing pollutants from sugar industry wastewater or SIW. The method being used is a simple double-chamber microbial fuel cells was configured with Nafion 117 membrane and operated without adding any chemical mediators. Sugar industry wastewater used an electron donor and was fed in batch mode into the MFC for 3 consecutive operational cycles. While the maximum MFC output voltage is in open circuit mode was 890 MV after 24 operational days, the closed circuit voltage was 340 MV when 550 ohm as an external load was applied. The result shows or demonstrate that proton exchange membrane or PEM was affected by biofouling in a 2-chamber H-type MFC, which would significantly affect coulombic efficiencies and maximum power densities, leading to reduced power generation. For the conclusion, from the polarization curve, the maximum power density of 160.16 MV per M2 as power output was observed at a current density of 320.9 MA per M2. The efficiency of the MFC was measured based on coulombic efficiency and chemical oxygen demand or COD removal rate. While the CE was 46%, the COD removal efficiency reached 85.4%. The anodic biofilm was observed through scanning electron microscopy or SEM. The current study results indicated that SIW microbial communities in the anodic biofilm have the ability to produce bioelectricity using MFC in parallel with the SIW substrate treatment. And here are my references. That's all, and thank you for watching.